Have you ever watched a piece of magnesium ribbon burn in air? It sparkles with a bright white light, leaving behind a white powder. That magical moment is a direct combination reaction in action. So, what exactly are these reactions? A direct combination, also called a synthesis reaction, is when two or more substances join together to form a single new product. Chemically, we express this as a plus B gives up, written as a plus B forms up. Now, what's fascinating is that these reactions are usually exothermic, which means they release heat or light. Like magnesium reacting with oxygen to form magnesium oxide, and here's something relatable, the same type of reaction makes fireworks dazzle during Diwali celebrations. Let's dive deeper. Many direct combination reactions occur between elements, especially between metals and nonmetals. Take this classic example. When iron and sulfur are heated together, they form a new compound called iron sulfide. That's Fe solid plus S solid gives FeS solid. Simple, right? But incredibly powerful. Another everyday example is burning carbon in oxygen to get carbon dioxide. All of these are examples of redox reactions where the metal donates electrons and the nonmetal accepts them. And just imagine, this simple principle is behind how metals corrode and how fuels burn. You'll see a visual on screen showing iron filings burning with a golden sparkle. Quite spectacular. Now, here's an interesting twist. Sometimes two compounds combine to form a new compound. Like this. When calcium oxide, also called quicklime, reacts with water, it forms slaked lime or calcium hydroxide. This reaction is so exothermic that you can feel the beaker getting hot and you'll see a milky white suspension forming. Where do we use this? In whitewashing walls. That milky coat you see is a direct combination product, helping buildings look fresh and bright. You'll see the diagram showing the heat being evolved, almost like chemistry in action. Sometimes a compound can react with an element to form a more complex compound. For example, sulfur dioxide gas reacts with oxygen gas to form sulfur trioxide, a key step in manufacturing sulfuric acid. This isn't just textbook chemistry, it's the heart of the contact process used in fertilizer and chemical industries. And the secret ingredient? A catalyst called vanadium pentoxide or V2O5, which makes the reaction go faster. Look at the visual on screen showing the industrial setup, chemistry scaling up to meet global needs. Let's talk energy. Most direct combination reactions release energy. That's why they're called exothermic. Imagine an energy profile diagram on your screen. It starts high with the reactants and drops down sharply to the stable product level, indicating energy release. Take this reaction. Hydrogen gas plus chlorine gas gives hydrogen chloride gas. The reaction is so exothermic it actually produces a bright flash of light. These reactions can be explosive, so they must be handled with care. So, in essence, direct combination reactions give us both heat and light, a powerful combo. Now, let's move to the lab and industry. One of the most important synthesis reactions is the formation of ammonia through the Haber process. It goes like this. Nitrogen gas reacts with hydrogen gas under high pressure and temperature to form ammonia. But this reaction only happens efficiently with the right conditions. We need a temperature of around 450 degrees Celsius, a pressure of about 200 atmospheres, and an iron catalyst with molybdenum as a promoter. This reaction is the backbone of fertilizer production. Every time a farmer spreads urea on a field, it's thanks to this chemical miracle. Check the diagram showing the setup of the Haber process, from gas feed to catalytic chamber. Let's quickly recap what we've discovered today about direct combination reactions. They occur when two or more reactants combine to form one product, as simple as A plus B gives AB. These reactions can occur between elements, between compounds, or even between an element and a compound. Most of them are exothermic, releasing heat or light, and many play a vital role in everyday life, from lighting fireworks to making whitewash to producing ammonia for crops. These reactions are everywhere around us. I hope this session helped you see how chemistry is more than just equations. It's a living, breathing part of industry, nature, and our daily lives. Catch you in the next class with more fascinating reactions and real world chemistry connections.